All right, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV experimenters night. And apologies to those people who were following us earlier, or trying to follow us earlier. We just had a minor technical hitch, which involved me not starting the stream. So we'll get underway slightly later than what I initially envisaged. We right? Okay. Thanks, Ben. I've got Rex, VK7MO, in the studio, and I apologise, Rex, we're going to have to redo the first couple of slides. But Rex has been experimenting with auroral propagation, so I'll hand over to Rex.
Thanks, Justin. Yeah, well, back in January, I tried out the digital mode Q65-15C, which means 15 seconds, and C means quite wide tone spacing, to see how that would work on Aurora. And I gave a short talk here in early January. Actually, the opening was towards the end of December. And it showed that it looked very promising, and so I've been looking for another example to explore this a bit further. I've been involving VK3MAP, who's got a very good takeoff to the south, and I've had help from Dr. Andrew Klekociuk at the Antarctic Division, who originally was recruited as an auroral physicist, but has moved on to lots of other upper atmosphere or atmospheric physics projects.
Which we heard about. He gave us a talk a little while ago. So,
yes.
About his project.
And he's very interested in helping out with this. In fact, we hope together we'll publish a paper for Dubis on this work.
Okay.
Now, this particular opening on the 27th of February was what I would regard quite spectacular.
Okay.
It lasted for about 14 hours, and signals were very strong. In fact, the strongest signal was plus 8 dB.
Oh my goodness! Yeah, okay, super strong.
So
that's SSB levels.
That's right.
Well and truly.
Next slide. Now, a quick overview. Auroral QSOs were made with VK3MAP, 3DXE, 3KZM, and 3AXH, all in southern Victoria. Although 3AXH is at Ballarat, and he's at 37 degrees south, which is a long way north for Aurora.
Correct.
All stations just being south. We didn't do anything to search for auroral peaks or anything. VK3MAP monitored my signals most of the time. There were a fair few gaps where we tried other modes and tried single tones. I even tried some voice and got through on voice.
Okay.
But very distorted. But in the period he was receiving, over that period, he got 800 decodes with just one false decode.
Yep. Okay.
Now, the auroral signals are readily identified by changes in doppler off the Aurora. I can't receive any of these stations if I beam south, which I have to do for the Aurora, but what I tend to do with 3MAP, whose name is Brody, is I'll beam at him and he can receive me direct.
Okay.
And that establishes that we're both on the same frequency and everything is working and we've chosen the right modes and things like that.
Cool.
But then when we beam south, usually nothing happens and you're waiting for some Aurora to build up, and basically you just run all night.
Yep. Yeah. And things start popping out when the Aurora appears.
Now, Brody had a technical problem at his house, in as much as he only transmitted up until about 11 o'clock at night, when his partner said, the fan noise is stopping me getting to sleep.
Right, okay.
So he had to stop, but he still listened to me over the whole night. And so he got some 800 decodes, which is enormous.
Phenomenal, yes.
And there was one false decode. I also got one false decode, which we'll look at later. In the period I was looking at him and others. Now the Q65 mode runs in 15-second periods, so this tends to give a reasonably short time if the Aurora is changing, the Doppler is changing the frequency.
Yep.
And the tone space of 26 Hertz is wide enough to cope with a lot of the spreading, but not completely, and so you will lose some periods, I suspect, for that reason. It works well with 100 watts of signal yagi. Brady was running 100 watts. He was running an 8/8, and I was running a single yagi, but it's fairly modest sort of.
That's within the reach of, because most modern rigs put out 100 watts on 2 meters. So
yes, I'm not sure I'd run 100 watts overnight out of a modern rig, transmitting 15 seconds on and 15 seconds off. So we both actually put it into a linear and break and back it off so that it's not.
Let the linear do the work.
Yes.
Okay. All right.
Now it turned out that while there was a nice Aurora predicted, it was cloudy in Tasmania, and so we saw absolutely nothing. And so I've looked around on the web and found that in New Zealand they had clear skies, and this is an image that someone took on the west coast of the South Island from Fox Glacier.
Phenomenal image.
Of the Aurora on that night, so it was pretty spectacular.
Oh, truly. And the Milky Way in that shot as well.
Right.
That's fantastic.
Now this is a shot on the 21st of February. We missed this event, and the reason I put it in is it is quite of different nature to the normal Aurora, and this is something that's only been relatively recently discovered by amateur auroral photographers. A few years, but and this phenomena is called strong thermal emission velocity enhancement. Now,
otherwise known as Steve.
Yes. I think they thought the word up Steve and then thought the acronym after it.
Right.
But I don't know. Now, Andrew is actually very interested in the possibility that we might get a reflection off of Steve, and because of the velocity component, it might be different to the auroral component. And so we're not sure whether anything will be possible, but there's an opportunity to do some more work.
And it certainly looks different.
Yes.
Like that's quite different to an Aurora.
Yeah. Now, most of these Steve events have been discovered or photographed at a time when there was Aurora. We don't know whether they're available at other times. It may be that the only time people are looking for Aurora is when they see them, because they're photographing things.
Yeah.
So, now some history. I was sort of researching the background to auroral propagation, and I found a paper from the Max Planck Institute in Germany from the mid-1960s, and it referred to the first radio observation of auroral reflections, and the reference they gave was to QST. And it is possible in this day and age to just go on the web and find copies of QST all the way from when it first went on when it was first published,
Yep.
up to about 1962. And so
Okay.
I went back to this. They gave the references QST May 1939. I went back and I thought this was really interesting. These guys were sending CW on 56 megs. In those days, the 6 metre band was probably 5 metre band. All these bands were multiples of, 3.5, 7, 14, 28,
all the way up.
56.
1, 2,
1, 2, and probably 224
Yep.
and so forth. And this guy just called CQ, and he received this other guy who was, it turns out, about 600 kilometres away, which on 600 on 6 metres in those days was something that probably didn't happen.
Yeah.
But the strange thing was this guy's signal was very peculiar, he said.
Unintelligible.
Unintelligible. Well, he could copy the CW okay.
Yeah.
He did try some SSB, but the SSB was... I used the word SSB. He tried phone, which in those days would be AM, clearly.
Correct.
And phone was unintelligible, and these are all the characteristics we see with auroral propagation. Brodie and I did have an SSB contact, and we got through okay, and we did... I think we would have struggled if we didn't know each other's call signs.
Yeah. Okay.
But we did exchange signal reports which were unknown and proved to be correct after the event, so...
Okay.
It was a legitimate QSO. The interesting thing to me is he didn't refer to CW as CW, he refers to it as ICW. And when you think about it, well, I first had to look up the web to see what ICW was. And I found that ICW is intermittent CW. And it occurs to me that is a far more accurate description of what CW is.
Correct.
Because CW is a continuous wave, which is just a carrier going on forever.
No, correct.
But Morse code, when you send it,
Dits and
does is intermittent CW.
I love it.
Then I love the end of this little article where he says the signal after about 9 p.m. the W8VO dropped out of the picture, just like someone cut the wires with a pair of pliers.
That's it.
And this is an example of auroral scatter where once it disappears, it disappears.
Can I say auroral scatter and also 6 metres? Because 6 metres can drop out.
Oh, well, that's more to do with strategy. But
correct,
yes.
Correct.
So
very similar.
I thought this little historical article was amusing. Yes.
And the fact that a very well respected institution like Max Planck made reference to it.
That's right.
I love it.
Okay. Now this is an example of the decodes on 27th of February. You'll notice that the dB level in this particular example sort of varying from -9s to as good as -4s, which on WSJT is a very strong signal. You'll notice that there are 3 different stations here who have all been calling me at different times. And you will also notice under the frequency heading that the frequency is varying significantly. That's a maximum of 1276 Hertz and a minimum, I think, of 1109. Now, we're actually transmitting on 700 Hertz. So even at 1109, it had shifted at 400 Hertz.
Well and truly.
And then it was shifting even more up and down around. It's in that 400 to 500 Hertz range.
Wow. Okay.
And this is because you're reflecting off little particles that are all travelling at different speeds and producing different Doppler shifts and so forth. Because we've got fairly wide beamwidth antennas that are picking up Aurora from lots of different directions and stuff. And it's decoding perfectly.
It's well and truly. And Q0, Q2, Q3 is the worst. That's
yes.
So degree of confidence
is
very high.
Yeah.
And signal levels are very strong.
Yes. Now we'll go in a minute to a spreadsheet. I just wanted to point out that the second line here, you'll see there is an obvious false decode. Second bottom line.
Bottom line, yep.
An obvious false decode. But at this same time, I've got 3 stations calling me, a bit of a pile-up. 3DXZ, 3AXH just a bit earlier, who may well have been transmitting still, and 3MAP. And it's highly likely that the combination of all these stations, all mucked up by Aurora on top of each other, produce this one false decode.
Okay.
Usually false decodes you can pick because
wrong call sign, wrong grid locator, etc.
Yes. I'm not even sure where EE is.
I'm not sure there is such a thing.
No.
All right. Now we're back to where we started. where we got to before. So,
okay, are we at the top? Yes.
Yep.
Now we just sort of scroll down and you can see the audio frequency about here has dropped from about 1,000 hertz down to 520 hertz.
Yep.
That's actually not real. That's happened because Brody knocked the tuning knob on his radio. I should explain, poor old Brody has a 9-month-old baby who he seems to look after most of the time.
Right.
And he's usually trying to settle a baby, feed a baby, and do things as well. So, understandable that he might have knocked the tuning dial.
Perfectly understandable.
But you can see, nevertheless, the signal levels are quite strong, 0 dB. And if we go down a little bit more, you can see Brody corrects.
Yeah, yep.
Now, the reason why it took so long for Brody to correct is we had set this experiment up and then I had gone shopping, and when I got back, I noticed the frequency was way down and it dropped from 1,000 hertz down to here. And I rang up Brody and I said, something funny happened. Any chance that you change frequency? And oops, yes.
Right.
So now we just sort of roll down. You can see there's an odd exchange of a signal report and an RR73 to indicate that we completed a QSO there. I think Brody and I completed 3 or 4 QSOs, but mainly we just transmitted to each other.
Still really high signal levels.
And just keep rolling down and now about this time you'll notice
there's the false decode.
There's the false decode, and you'll also notice that about this time the frequency is actually dropping. And this is real because by this time Brody and I had assured each other that nobody was knocking receivers. And we keep going, and
back up again.
now you can see signal levels dropped off of -11s or something like that.
10s,
-10s, and so forth, and keep going. Here's 2s and 3s and
back up to that strong level,
Yeah.
but right down in frequency.
Yes, right down around 300 hertz, and I think you'll find even 200 hertz somewhere in there.
Okay.
Now, I think that you just keep going, and there's something like, if you go right to the bottom, you'll see on the left hand side no, you can't. It's not there. But there was actually 778 decodes.
Yeah. Okay.
So almost 800 decodes.
Yep.
And this is by 2049 UTC.
Yep.
It clearly dropped off dramatically after those decodes around 1914 and 16.
Yep.
And there was just a few decodes after that. So the guy didn't quite cut the wire with the pliers.
Not quite, but
it
tapered off in a digital sense.
That's right. So now what I've done here is I've plotted in red dots the actual audio frequencies and also the signal levels. Now, the signal to noise levels we'll just focus on first. The best signal level was actually plus 8 dB.
Okay.
I think, unfortunately, the way the colours are, that some of those black dots are really red dots.
Mixed in,
But 8 dB was the strongest, and about minus 17 was the weakest decode.
Okay.
You leave aside the little patch at the start where it went dramatically down by 500 hertz, which was
this one. Oh, hang on. No. Sorry, I'm on the wrong screen. It's this little area here.
That will put down to inadvertent mistuning. But aside from that, if you sort of look at the red, it's been quite high,
and then
fairly dramatically goes low. Now, Andrew and I are still trying to get a handle on this, but there is evidence in the literature that is what is real.
Okay.
And it seems like it happens about midnight. Now, it's not midnight.
Approximately 11, 13.
Well, that's UTC. So,
okay. Yeah.
But it's about midnight. And some of the research papers suggest it happens at what they call magnetic midnight, which is not the same as...
Okay.
Because...
I've never heard that term before.
Yeah.
We've got another midnight.
Because the magnetic poles are not lined up with the geographic poles.
Right. Okay.
Further than that, the auroral magnetic pole, which is a magnet out of space, is not even lined up exactly with the south magnetic pole.
Yep. Okay.
So it's a bit more complicated.
Okay.
But it's certainly interesting to note that the frequency jumped fairly rapidly.
Okay. Yeah.
And we're trying... obviously, there are answers to these things in the literature, but we're trying to convert what's in the literature into language that us ordinary hams can understand.
Okay.
To explain what's actually happening.
Okay.
But it does look like the shift, which is basically plus or minus 400 hertz around 700 hertz.
Well and truly.
If we look at the actual signal strength, you'll see it drifts up and down, but most of it's sort of
pretty. If you put an average line through that,
it's about a minus 5 dB.
Well and truly.
So now there are a lot of gaps, and those gaps reflect the fact that we tried other things like different modes, tried a bit of CW, tried a bit of
voice and
SSB, and we actually transmitted some single tones so we could look at the spreading of the signal and things like that.
Okay.
But clearly, the only way you could get information like this is with a digital mode. You couldn't get it with.
Well, true.
with listening to CW
Correct.
or phone or
Correct.
anything else, and you'd get sick of yourself before after 14 hours. But so this is an advantage of this way of doing it. So
And it's all automatically
recorded.
Correct.
Now we did try some single tones. We tried this at a time when the signal was very strong, because it's generally very hard to see anything on the waterfall. But at this time, it was around plus 4 dB on Q65 when we switched to single tones.
Yep.
And you can see there's a bright area that's about 200 hertz wide, but it's actually spread nearly 400, perhaps even more hertz. So it's
Keep talking.
it's a very spread signal, and when you bear in mind that the tone spacing's only 26 hertz, it's got to pick the right tones, the 65 separate tones out.
Yep.
In a signal that is spread like this. If we go to the next slide, this is what a coronal mass ejection looks like, and this is what causes these big auroral events when lots of plasma enters the Earth's magnetic field.
And I'm awfully glad that we've got a magnetosphere that pushes most of that energy around us.
That's interesting, because back in researching this, back in 1840 something.
Oh, the Carrington.
Yes,
Yeah, the
there was this
Yes.
great auroral event which
Correct.
they predict if it happened now it would wipe out most of the satellites.
Most of our communications.
That's right. So in that respect, it's important to understand some of this stuff.
Well and truly.
Next slide. Now, these coronal mass ejections
Keep talking.
actually derive from sunspots, and they take about 2 days to arrive here. And these two pictures are at the 25th and 26th, and the event occurred on the 27th. And you can see some quite strong dark sunspots
Some real patches.
up there. Can you point them? Yeah.
I can.
Yeah,
Up
there.
here.
Yeah. And Andrew thinks these were the cause of the
Especially that one.
of the propagation. I mean, just because they're there doesn't mean there's propagation. They have to explode into a...
They have to shoot energy in our direction.
That's right. But Andrew's view is that providing they're basically on the meridian, up and down,
Yep.
or close to it, in fact he says with up to 45 degrees either side, there's a fair chance that they will hit the Earth.
Yeah.
And
Because that's exactly right. There's lots of coronal mass ejections from the sun that we get fantastic photos of them going off in another direction.
That's right. But we want them to come...
a profile shot, but you know,
Yeah.
the thing we don't want is them to come in our direction a la Carrington.
Yeah. Okay, next slide. Now, in order to forecast it, what we've been using is a NOAA forecast, which gives a 3-day forecast, and essentially NOAA actually like to call things G1s, G2s and G3s, but the historical method is to use what's called KP index.
Yep.
And
that's the one that the Aurora watches use.
That's right. Not absolutely spot on, but it gives you a clue that it's worth going out or starting to transmit and have a look. Now, The forecast actually went up to 7 on this day, and 7 is very high.
So what's the maximum? What's the
10.
Yeah. Okay.
Probably a logarithmic scale, but I'm not even sure. But
no. Okay.
I think 10 means it gets the equator. And
Yeah. Everybody in the world sees it.
Yes.
Yeah, okay.
But I think I've actually, in the past, when we used to use Hellschreiber for this stuff, I've seen signals up into New South Wales when it was 9 on this scale. So I think there's still opportunities for...
I'm trying to remember, Rex, because I remember when we first got to Tasmania in the 1990s, early 1990s, I remember there was an event, a quite significant event, because I remember hearing on, I think it was 6 meters, this really weird, what I'd describe as almost machine gun, sort of really rapid, and going, what the hell's that? And thinking it was some sort of mode that I didn't know anything about, but then talking to amateurs later, they said, there was this fantastic aurora, and I sort of went, okay.
Yes. Now, interestingly enough, aurora peaks at the peak of the sunspot cycle. We've got about 2 more years to get to the peak.
Correct.
So now that we've got a method of monitoring it essentially without having to stay up all night,
well,
I think there'll be a lot more opportunities to get that over the next couple of years.
Oh, definitely.
Now the problem with looking at the forecast is the forecast tells you when the KP is maximum, but it doesn't tell you when the auroral oval is closest to you.
Okay, yep.
And for that, we have to go to another NASA site. Well, the same site, but another part of it.
Okay.
And you can see here that at the middle of this opening, the aurora was here almost up to, well, in fact, probably into southern Victoria.
Well, truly.
But towards the end, the peak of the aurora had gone towards South Africa.
Yeah.
The oval was pointing that way. And even though there hadn't been a dramatic change in the KP index, it had pulled away from Tasmania.
Yeah, okay. So that's where those signals were tapering off.
Tapering off.
Okay.
At about 1900.
Yep. Yeah.
Yes.
So that's as the Earth rotates.
Yes, and the key to this is, and I must admit I don't yet have an explanation for it, is the auroral oval tends to be pushed off towards the night side of the Earth.
Okay, yeah, which you can see.
That's right.
Correct.
And so the best time is when you've got a high KP index and at the time when it's midnight or at night.
Well, truly.
At night.
Because that intensity is thickest in here.
Yeah, now whether the signal reflects from that very intense stuff or from here they're all open questions and interesting things to learn.
Good stuff.
Next. Now this is to demonstrate this effect on a day when the KP index was very low, and you can see that the aurora is well towards us in the middle of the night and well away from us in the middle of the day.
More South America and Africa.
That's right. Now there's one more thing to note, is that the centre of the oval, and we're very fortunate,
is offset to us.
Offset to us.
I saw that.
Yeah.
Well and truly.
No.
Because it's on that the where it's on the other side.
Yeah.
It would be fantastic on the Antarctic continent, but
that's right.
That's about it.
Now, it turns out the the actual south magnetic pole, if you're at the surface,
Yep.
is pretty close to the coast, about De Monteville, say roughly south of Tassie.
Yeah, okay. So we're talking in here somewhere.
In here, but the centre of the Auroral oval is
Is
somewhere about there.
yeah, okay.
Even so, we're very lucky because
Oh, well and truly.
that distance is something like about 1,600 kilometres,
Okay.
and because that means we're advantaged by 1,600 kilometres, and people on the other side are disadvantaged by 1,600 kilometres.
Yep.
It puts it 3,200 kilometres closer
To us.
to us.
Truly. I love it. I love it. All right.
So, the best time to try to this day of mainland is a KP forecast of 5 or more during the evening.
Yep.
I should say that for tomorrow morning about 6 o'clock to 8 o'clock, there is a KP forecast of 4.3, and so we're actually going to have a go even, because
Right.
there's some encouragement
Okay.
there
Okay.
just to see what the limits are.
Okay.
Uh,
And between the
and between those times. Now,
Yeah.
it's not really related to daylight, because this is all a function of the magnetosphere,
Yeah.
and obviously our daylight is much less in the summer than it is the winter, but that's not going to be an issue. It's related to the magnetosphere.
Okay.
Now, why it is that it's better when the solar wind is sort of on the flowing past us at
Yep.
night, I don't fully understand, and Andrew's probably going to try and explain some of these things to me when we get a chance to get together.
Cool.
Next.
Slide.
Now, what I've done here is I've actually plotted the frequency of that single tone that we saw before. And you can see, and the blue lines is one bin width of 26 hertz. And you can see a lot of the time the signal is going to be outside the 26 hertz.
But it's still decoding.
It's still decoding, and I think the reasons are as follows. First of all, when it establishes the sync tone, it's going to be the average of the whole period, and the average will be pretty well straight down the middle.
Yeah.
And
Okay.
so that's right.
There's enough within that 26 hertz.
Yeah, to get the sync tone averaged out.
Yep.
Then, in terms of the actual message tones, most of them are still within the 26 hertz.
Okay.
And because WSJT has a lot of redundancy, it can cope with
Yep.
a lot of missing tones.
Total. Yep. Okay.
And it has even more redundancy if you actually run in SCED mode, where the call signs...
It knows the call signs.
The call signs.
Yep. So it knows what it's looking for.
That's right.
Yeah, yeah.
And if we go on to the next slide, we'll see the two-way Doppler shift. The red dots are what I received from Brody, and the black dots are what he received from me. And there's a fairly good correlation between them. There's some there at about that start, which is when the dial was knocked, but
Yeah.
but generally, I mean, it's not exactly at the same time, because he's transmitting 1/15 second and I'm transmitting the other, so you wouldn't expect them to be spot on, particularly with the variability from one to the other. But in general, it's a two-way Doppler.
Well, not really.
Yeah. This terminates at 11 UTC when Brody's partner decided she wanted to get to sleep.
The fan noise.
The fan noise.
Okay.
Next slide. Now, what I've done is I've looked at various decoding options that are available in WSJT, from fast, normal to deep, and effectively what happens is if you dig deeper into the decoding process, it takes a lot more time to decode.
Yes.
And it can usually pick up more signals.
Yep.
For normal, say, situations with solid signals, there's very little difference with Q65 between fast and deep.
Okay.
But I think the reason there's a much bigger difference in this case is we're dealing with these tones that a lot of them are coming in and out and so forth.
Yep. Okay.
But it does mean for the time that Brodie was actually transmitting was only 292 TX periods.
Yeah.
And on deep, with the call signs known, we got 95% of the decodes.
That's pretty good.
Yeah. With my own call known, but the DX call and grid blank,
Yeah.
that dropped to 63.
Yeah. Okay.
But
that's still 2/3.
Yeah, that's right. And bear in mind, these are cycling every, 15 seconds.
Yep.
So you don't have to wait long to have another try.
Yep.
And in fact, most of the other stations I worked, I didn't have their call signs and grids inserted, and
Yep.
yet I got through.
Well and truly.
And so forth. Clearly, if you go to fast, it starts to drop off quite a lot.
Yeah.
Personally, I'm not worried about that because if you're if you're in deep, the decoding time will continue well into your transmit period, and you can't change the message.
Yep.
You only got to wait another 7 seconds, and you're transmitting the changed message.
Yep.
So I'm using a fairly good computer to do this,
Yep.
but I think you're quite okay to run in fast and just accept that you won't change the message.
No. Correct.
A little bit later. Okay, now just to conclude, here is a montage of images of Aurora in Tasmania that I picked up off Google. And it's sort of amazing.
of that event. Is
No, not of that event.
No, okay,
No.
okay,
Some of these go back 20 years or something like that.
No. Okay.
And most of them are actually from Cradle Mountain across. I don't know what lake that is. But
Dove Lake.
Dove Lake.
Okay. Yeah. No. Well, Ben mentioned that there was apparently a bit of a traffic jam up on Mount Wellington.
No, I actually mentioned.
Oh no, you mentioned it. Okay. Yeah.
Yes. Andrew told me that a whole lot of people went up Mount Wellington for this event, and there was a traffic jam, but it was cloudy. They saw nothing, and then about 3 o'clock in the morning, when most of them had gone home, there was at least some of them saw Aurora through patches of cloud.
An opening in the clouds. I love it. I love it. So those people who stuck with it
did get something to see, but to get visual Aurora, of course, you've got to be a bit lucky with the clouds. But for radio Aurora, it's not an issue, and I think with digital modes, this is going to be seen far more often.
In fact, we're probably in the privileged position of being able to tell whether there's an Aurora there, even though you can't see it.
That's right. Yes.
Correct.
It's not absolutely clear that the visual Aurora is the same region as where the ionisation reflection is from.
Okay. Well, that's an interesting question.
Which hopefully we might be able to answer. Okay.
So fantastic. Oh, that is excellent, Rex, and yeah, just I think there's a whole lot of questions in there.
Yes, and I think over the next 2 years there will be a good chance of answering some of them.
Well, and truly, if this is what we're getting, and we're still 2 years away from the peak, the sunspot peak, and in fact, we're doing even better. I saw that plot the other day where they've plotted what the sunspots are actually doing versus what's been predicted, and that's a whole lot better than what they were predicting anyway. So if it continues in that sort of trend,
Yes.
we're in for a pretty good couple of years, 3 or 4 years, because of course it's got a peak and then it's got to drop off again. So we're in for hopefully some wet pieces of string operating. So yeah. Now stick around, Rex, because the next thing we'll do, I was going to do the Cariboulite next, but I have actually allowed Ben to to head home. What we'll do is the Cariboulite next week.
Right.
Which is fine, but in association with this, I spent a very enjoyable time on Sunday having lunch with David Brunet, who is FT4YM. So for those out there who recognise that call sign, that's French call sign. Now, and just before Christmas, he put out a bit of a call. He said, "Oh, please, I'm looking for a linear amplifier because I've blown the finals up in my I think it was an FT100, which he ended up being able to fix. But we sent a 200 watt linear amplifier down to him, and he was actually able to use that linear amplifier whilst he was traversing in to go and get an ice core."
Yes.
So he was actually Antarctic mobile.
Yes. On the ice cap.
On the ice cap. So my wonderful little Tokyo high power linear amplifier that I managed to get onto the boat down to him ended up traversing the ice cap.
Yeah, coming back.
But what David shared with me was some photos of his time, some highlights of his time. David is actually he's Frenchman. He lives in a little town called Grenoble, which is on the near the Italian border, up in the Alps. And he loves mountain climbing. He loves mountaineering as one of his other hobbies, as well as amateur radio. He's got a family he'll be back with his family by now, because he left on Monday to fly back. So he will actually be probably traversing his way across France from Paris. He was a bit worried because he was flying into a Paris where there were significant austerity strikes.
Yes.
So he was a bit worried about actually getting from Charles de Gaulle into Paris, and then from Paris out to where he actually lives. So what I will do here is the close-up camera. I will zoom in and I will quickly show you these shots. This is he went to and from on the
Astrolabe 3.
Astrolabe 3, so it's the third one, and there's some pictures of Astrolabe. It is quite a small boat. It's run by the French military, by the French Navy, but he had some shots. This is 2 of the helicopters that they were taking down there. So this is pretty impressive to fit 2 helicopters in a hold in a ship that's not actually quite that big. It's smaller than the Aurora Australis.
A lot smaller.
A lot smaller. Much smaller than Noyina. But so this was, and he said, it does bounce around a fair bit. Lots of people were sick on the boat. This is it in I think when they were actually at Dumont Deville.
Yep.
And unloading and bits and pieces. Not quite sure why he took that one, but anyway. This is a video he sent. There's a little bit of swell there, and as Rex pointed out earlier, he said if somebody's taking pictures and video, it's not very rough.
No.
But there's a bit of but you can see the boat sort of go swaying and going backwards and forwards here. some cloud shots, some sunset shots. Icebergs. So they must be getting close to the Antarctic Circle, the close to the mainland. Now this is Concordia Station. So he was no.
No, this
This is de Monteville.
Yeah.
Oh, because of course it's at sea.
Yeah,
You're
right
looking
on the coast.
You're looking at the sea.
Yeah.
Well and truly, Concordia is way inland. And you can see lots of, I think they're little penguins sitting there. Some nice sunset or sunrise shots. A few sea shots. Don't know. No, well that would be Demont as well because that's looking out to sea, I think.
Yeah.
This is on the boat. This is well that would be a refueling line, I suspect.
Possibly, yes.
Across here, you can see there's a line here.
That looks a long refueling line to me.
It does. It looks very long. All the chains on the boat. Now this is number 3, Astrolabe 3. Aviation turbine fuel. That would be for the helicopters, I suspect.
Yes.
On the boat, looking out, another helicopter. Oh, very nice shot. Very nice shot of I suspect a sunset. Some tractors. Now, there it is in the harbour. Oh, we got that again. Oh, okay. More helicopters. He sent me a whole bunch of stuff. Some of the machinery. Now there's some shots of the Traverse. I'm actually not quite sure what that is. Here we go. Now, he was involved in a Traverse out. It was a week out and a week back. So however fast the tractors go, this convoy goes. And he said he described quite a definite cycle that everybody went through because everybody was helping with everything. He was on duties looking after refueling each night. They had to refuel each of these machines. They were using something like 800 litres of fuel a day, or something like that. And he said, and the only way you could refuel these vehicles was to actually be outside, actually physically refueling these tanks. So he said that wasn't a nice experience. But he said the main one, which I think's this one at the front, those two at the front with the tractor and the trailer, which is the actual drilling rig, there's 700 tonnes. Wow. It just huge, and they had to keep all the diesel motors going, all of the drilling motors going. They had to make sure that all the refrigeration was going. He said they had a very unfortunate scenario where they'd actually got one of these cores and they put it into refrigeration, and the refrigeration failed,
and they lost it all,
and it melted. And so he said there's a whole procedure around the refrigeration now and all of this sort of stuff. So it's just all of the things you take for granted. That's that sort of thing. So this is part of it, part of the convoy with all the I assume the fuel that was going with them. I think you said that was a DC3?
I don't think it is. Now, when I look at it. No.
With skis, so a bit different to the plane that we use, because our plane's got wheels on it, doesn't it?
We do sometimes use ski-equipped ones on the continent.
Oh, okay. How do they slow them down, just as a matter of interest? Do they put the motors in reverse or something?
I'm sure they do that, but they also need very long runways.
Yeah, okay. Because I thought they
do land them with a bit of snow on the ice, so there would be.
So there's a natural friction. Okay. Oh, I just thought about that because I just went, oh, okay.
I think they call that aircraft a Bassa. I don't know what that means.
Okay. the type of aircraft.
Yeah, if Kim's outside, he'll know.
Yeah, if you are Kim. This is them on the Traverse, so you know, all freezing. This is them. I think when they arrived via plane. He went home by Astrolabe. This is looking back along the convoy. That's me. Just stand by, because I do have a picture of David. I remembered to take a picture of David. Where is it? There it is. So this is David and myself. We, after lunch, we so it was him and 16 others that all came back at the same time. He said it was a bit disappointing. He said they came into to Hobart on Astrolabe and then sat in the Derwent for 4 days.
Why?
Don't know. He said we don't know at all. He said they went up to Self Point, they refueled, came back, and then they were able to dock and people were able to get off. So he said that so close but so far.
Sounds like a COVID sort of something or other.
Or a quarantine sort of thing.
Yeah.
But anyway, so that was David Brunet FT4YM, and I was very lucky to we exchanged QSL cards, and the thing I really like about this is this has got the postmark on it from Concordia, very similar to the postmark that I got from Warren from his QSL card, his postcard from Warren, which has an actual postmark that's postmarked at Concordia. And so this is his QSL card. A big thank you. Perfect amateur radio spirit, which is fantastic. That's him operating. And I gave him my own QSL card with a mode of eyeball QSO in exchange, as well as bought him lunch. So that was I'll treasure that particular QSL card. It's good stuff. So anyway, that's our. I'll just make sure. And Lionel, KJ7OFH. From New York State, who comes in. He's a regular watcher. We've got Ron online. We've got Gary, JGD, and we've also got Richard. And I just made the comment to Richard. Richard and myself have been involved in a major incident at a data centre very early this morning. So we've all got toothpicks in, holding our eyes open. Because we were all up for all hours. So Richard, please go and get some sleep if you're still there. So I managed to get a few hours of sleep in this afternoon. So, but I can guarantee I'll flag in a minute. So. That's our show for today. Apologies for the late start, and thank you to Ben for pointing out that we were not streaming at the time. So we repeated the first bit of the talk, but we're back underway next week. I had 1 hour. Oh dear, Richard, you need to sleep. You need to have a good sleep and catch up. Now, just finishing off. Finishing off on a slightly negative note, Rex, can you pass me a particular item that's over there? We had for those who don't know, we had some very strong winds recently as it came as a huge big southerly breeze blowed in from the south, and we had some pretty deadly gusts. They weren't actually that strong, but there were gusts that went quite strong. And for those who know my magnetic loop antenna, and we have David on the YouTube channel. So good stuff. And there you go, David Brunet.
Really? Did he listen to all this?
Good video. So fantastic. Thank you, David. this is the base of my magnetic loop antenna that unfortunately due to the wind fell over and it cracked. This is 100mm PVC pipe, high pressure pipe, and it fell over. Now there's a little hole in here that was in the bottom where I could get to the motor that drives the vacuum capacitor, and it obviously created a weakness that broke where that hole was, and fortunately the vacuum capacitor is still okay, and I have in the van another length of this particular pipe, but yeah, the mag loop
You've got
is
to undo it.
well, we can heat that up and actually pull it out. So I'm reusing the fitting. I have another one of them on order, but you've got to order them from the mainland. But so yeah, that's when you have gusts of wind and you don't anchor down the stand that it's on there. So that's the magnetic loop. Fortunately, it didn't bust the vacuum capacitor. So we'll be in business again, and I'll make another one of these over the weekend. But anyway, that's what the wind can do. And in fact, David, if you're still watching, David, that's the sort of thing you have to deal with in Antarctica, with the strength of the winds that are in Antarctica. That tends to break things pretty regularly. And Richard, the 1.8 metre dish has survived the last 2 weeks outside, so good, excellent, excellent. That's good, Richard. Yeah, anybody who has anything outside in the last couple of days, I wish them luck keeping it in the air or up or whatever. So there you go. Anyway, that's our show for tonight. We'll get underway next week. We'll feature the Cariboulite next week, along with some other interesting bits and pieces. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Nights, and it's good night from me.
Good night.
We'll catch you next week. 73.